In question 6, we have a current against potential difference graph for two components, x and y, whereas to suggest what these might be. Well, in x, as the potential difference increases, the current is increasing but at a reducing rate, and this then is likely to be a filament lamp. As the current increases, it heats up, the resistance increases, and so the current doesn't increase in the same proportion. Whereas for y, we have a straight line through the origin, and this is therefore obeying Ohm's law, so it is an ohmic resistor. Okay. In B, we have the two components in parallel with a supply of 9.6 volts of EMF and an internal resistance R. We're told the voltmeter reading is 7.2 volts and we're to determine R. Well, from the graph we can see that with 7.2 volts, X will have a current of about 0.50 amps and Y will have a current of 0.36 amps. That's simply reading off the graph for 7.2 volts, the terminal potential difference. We can then use the internal resistance equation. That terminal potential difference is equal to EMF minus the current times the internal resistance. So we can rearrange to give the internal resistance as the terminal potential difference minus the EMF over minus the current, and we have a terminal potential difference of 7.2. The EMF we're told is 9.6, and the current we have of 0.5 plus 0.36. This gives an internal resistance of 2.8 ohms. In C, part 1, we're to explain how the student should measure precisely the diameter of one of the wires in the cable. Well, they would need to use a micrometer, and they would measure in several places, and then find the mean of the results. In part 2, we're to determine the resistivity ρ of copper. Well, resistance is resistivity times length over cross-sectional area, and so resistivity is resistance times area over length. We have a resistance of 1.86 ohms. The area is, we have 17 strands, each with an area of pi r squared, which is pi times 0.06 millimeters, which is 0.06 times 10 to the minus 3 meters, and pi r squared, so we need to square that term. This is over the length of 21 meters. This gives a resistivity of 1.70 times 10 to the minus 8 ohm meters. In part 3, we're to determine the percentage uncertainty in ρ. Well, the percentage uncertainty in ρ is equal to the percentage uncertainty in R plus 2 times the percentage uncertainty in the diameter, as this term is squared, plus the percentage uncertainty in the length. In the expression ρ is equal to RA over L, all these terms are multiplied together, so we add the percentage uncertainties, and the area is linked to the diameter squared, therefore we need twice the percentage uncertainty in the diameter. putting the values in. This is then 0.02 over 1.86 for the resistance, plus 2 times 0.01 over 0.12 plus 0.1 over 21. Multiply all that by 100 to give a percentage uncertainty, and that comes out at 18%.